Hi everyone. I hope you can hear me well. There he is again. Yeah, what's up, Eli? I know it's late for you and you have to sleep, but maybe you can watch like 2 minutes. I don't know, what's the time now for you? Probably 8 hours more, stuff like that. I don't know, 1, I assume. 1 a.m. Yeah, my guess was correct. Yeah, so today is normal Project Euler stuff, starting with problem number 26. Last time I streamed was on Pascal's triangle. I'm currently not able to cut it and have it as a YouTube video. I wanted to do that at the end of this week, but my cut program, KDN Live, has a segmentation fault and I have no idea how to fix it. That's why I focused on blogging and some other stuff. Well, still doing the live streams as I don't need it for that. But yeah, so I think we can start. So as usual, we load the Project Euler download package. By the way, Eval, I'm still not using your script to show which project I'm working on because at the moment I always have it on the right-hand side anyway. But I hope I will integrate it in the future. So for everyone else, it's a script where you can see in the, like, somewhere on the screen which project I'm working on, which project I need help for, and which project I have done already or in the stream. Oh, by the way, I hope the microphone sound is better now. Or is it too soft for anyone? Then we need to download number 26. So yeah, the problem is the following. Sounds good, perfect. A unit fraction contains 1 in the numerator. The decimal representation of the unit fractions with denominators 2 to 10 are given. Yeah, okay. And then we have the recurring cycle in 1 divided by 3, 6, 7, and 9. Where 7 has the longest one with 6 digits. It's 1, 4, 2, 8, 5, 7, which I think is pretty awesome for different reasons. So find the value of d smaller than 1000, for which 1 over d contains the longest recurring cycle in its decimal fraction part. Nice little problem. Yeah. I hope so. Maybe I have 2 functions. So this will be basically 1 divided by 7, which has a length of 6. Then longest. I don't even know whether I need a function for that. So it's basically maximum of, I don't know, does this work? So it will be like, yeah, maybe something like argmax. I don't know, because it's not 7, because we are starting with 2. Let's just make it like this. I think the syntax should work, but I'm not 100% sure. So having the function, which takes an input n and well, it computes 1 over n basically, or length of the protocol cycle. For example, 64107, which is approximately 1.42857. Okay, so I don't know how to write this down without drawing it. So basically, having long division is the plan. So something like we have 1 over 7, and then the 7 goes into 1 0 times. So we have 0, then we have basically 10 1 times, then we have 3 left, get 1 0 down, rest 3, 28, so that is 4. Oh, I don't know. Rest 2, and so on and so on. So, oh yeah, well, basically, so in the end, it will turn out to be 10 divided by 7 again, and then we have to repeat, and we want to get the repeating lengths. So we have, starting with, let's start with these first, like all the ones with like 1 digit first, so that we always start with 10 divided by, I don't know, 3 divided by n. And we have basically this, I don't know, digits, and rest is 10 modulo n. Afterwards, we have rest. Basically, I don't know, something like this. And then we have start multiplied by 10. And we keep on going until repeating. So I don't know, while not repeating, and digits and rest aren't like, it's not equal to 0. And then we need to define repeating as false and rest is whatever. And we can maybe do something like that. So I have typed in using revise before, so that we can track the solution file and can just write reciprocal len of 7, hopefully. So this will end in the infinite loop. Should, if I would have done it correctly, but I have not. Okay. Oh, no. This is not correct. So this is, what have I done? I get this 3 here because it's, oh no, this seems to be correct. Why is the first one? Yes. Okay. Oh, but I don't do, what have I done here? This is rest times 10. Yes. Oh, Jacob. Diffrem. Oh, that's doing both at the same time, I suppose. No. Okay. I think I have to kill this window. What is this electron one? That code? Okay, it just closed itself. Okay. Yeah. Are you staying for a while, Jacob, or are you just M2EU? Have I seen you before on the stream? I'm not sure about that. Welcome, anyways. I think I've not seen you before, so what are you up to? Are you working with Julia as well? And what are you working on? Holy bear rounds, perfect. What did I want to do? Oh no, I have to switch to that. Okay, I hope we are up and running again. So yeah, this one is correct now. Now we need. Oh, are you doing live streams as well? Or just for fun? Oh well, I'm just doing it for fun as well. But, sometimes getting help from you. You started from repeating is not updated. Yeah, that's what I'm working on. So, are you working from problem number 1 to whatever, or do you have a different ordering as eval, for example? So, I don't know. It will not be really efficient, but basically I can save. I used start already. True. I think I just. This is much easier. I always use the dict and save true in it, but if I never save false, it's kind of useless. If start in used. Oh no. Well, it's kind of useless, I think. Len is equal to 0. Oh, I have to. No, I think I need the dict because I need to save at which lengths. Sorry. I need to save the lengths. Because of this one, for example. Then plus equals to 1. Normally there's no length, and this one is length minus use starts. Yeah, let's just try it out and see whether it works or not. 6. This is exactly what we wanted. How about 6? How about 10? How about 9? This seems to be correct. I'm wondering, does this work for... Oh, I think it should work. I don't know, what's a good one? This should have 6 as well. Yeah, okay. And then... Oh, I can actually... Oh yeah, that's true. It gets a little bit... I think, so eval uses sorting by... Yeah, that looks good. Sorting by number of people who solved it, because the difficulty rating is sometimes quite strange. I think I solved one with difficulty rating 25 in like 10 minutes or stuff like that. And it was really not that hard. So, and others such as time consuming. So I don't know. I think the ordering is kind of arbitrary. But the one by eval seems to be reasonable. And I'm just doing 1 to 100. And then I'm not sure what I do afterwards, as you're kind of not allowed to share the solution afterwards. So yeah, I'm not too sure about that. So what I wanted to do is, let's make this readable. What? Okay. 1000. So we actually want to go to 983. And then we have to check 983 again. Okay. Wow. How do I get more precision on that one? Is there any way? So the answer should be find the value of D. So it's actually 983. Oh, correct. That's quite fascinating. All right. Difficulty rating of 5. Yeah, and then I always want to go to the next one, but I can't. Quadratic primes. Oh yeah. So what I normally do is 983. Run my test cases. Oh yeah. Actual problem. And download number 27. Okay, let's read. Euler discovered the remarkable quadratic formula n squared plus n plus 41. It turns out that the formula will produce 40 primes for the consecutive integer values 0 to 39. However, when n equals to 40, it is divisible by 41. Yeah, that seems reasonable. And certainly when n equals 41, it's also divisible by 41. Yeah. The incredible formula was discovered which produces 80 primes for the consecutive values of. What? The product of the coefficients. Oh, because it's a minus. Ah, okay. Okay, minus 79. I missed the minus sign there. Considering quadratics of the form yeah, okay, where n is the modulus absolute value of n. Yeah, okay. Oh, this just, okay. I thought it's for this n, but it's actually for a and b, yeah. Find the product of the coefficients a and b for the quadratic expression that produces the maximum number of primes for consecutive values of n, starting with m equals 0. Okay. Okay, I'm just thinking, basically we have oh yeah, because it can't be bigger than, n can't be bigger than 1000. Oh no, this is only true for, okay, I'm not too sure about that. Basically again plus 1000. So this is the maximum range, maybe, but only because this one is divisible by 70. Oh no, it's not. Okay, it's not divisible by. Is this always the limit of this one? Is the question. Oh no, this is of course not, because here we have 1. Okay. And we need to. So I was just thinking we can have basically a loop over both of them and try them out. But it's kind of consuming, right? So we would have 2000 squared, which is 4 million, and then we need to check, I don't know, maybe 50, I don't know. Okay, probably not that many every time. Is there anything we can say about A or B. So obviously A cannot equal to B, because otherwise for n, what do we have for n equals 0? That's a good point. So B has to be prime. That's a good start. Let's have why is it so remarkable? That's a good question. I don't know. It's quite funny, isn't it? At least I don't know what remarkable in mathematics is. I don't think is well defined. It's often just unexpected, weird, and kind of funny. That's what I would say. So let's get to focus. So we have, oh yeah, you know me. Normally I like to I don't know whether it's dramatic finding. I don't know. Yeah, I don't know. It's I think this incredible is maybe a bit overblown, but because we tried to find an even better one, so we should be more incredible. So normally I like to program things from scratch, but I somehow like the primes package. So primes under 1000, which gives us this. Oh yeah. Oh, by the way, this one is not even included. So we probably can say that n is less than 79. I assume, because otherwise this would not be that incredible. So primes under limits, which is a terrible name. So for A, what do we have when? Yeah, I don't know. What is this even? Can B be negative? Like, is minus 41 a prime number? Probably not, right? I'm a little bit confused by that, to be honest. It was and still is. What is that referring to? To minus 41? What is? Oh. First, we ask the package. So it says it's not a prime number. cannot be prime. Yeah. Okay. That's my definition as well. So we have minus limits to limits for A, and for B we have in primes under limits. Okay, it's up to, do we want that? Yes, we want that, even if it's kind of unnecessary. But here we want to have this range. Now n is equal to 0, while is prime. Is that actually? No, that's a function. Okay. I don't know. I could probably do it in there as well. What did I want to do? I wanted to compute n is rising, and there we have p as the possible prime is n squared plus a times n plus b. If I don't like the, well, I normally don't like wild truths, but if is prime p, if not prime p, then break maximum n is 0, and if n bigger than maximum n, then maximum n equals n. Okay. Print line maximum n. And I don't know. Let's start with a limit of 41. Nope. Is 60. I don't know. Founds bigger. Oh, I think we want to do that outside actually. Found bigger for a equals $A, b equals $B. And I limit it to 1. Then we have length of 40, which is this one. A equals 1, b equals 41. Yes, that sounds about right. Now then we can leave that in and have 71. Okay, and now find the product of the coefficients for the quadratic expression that produces the maximum number of primes. Yes. let's call it best A and best B with the weird initialization. And oh yes, best B, product A times. Okay. Yeah, it's always taking long, and it's always taking longer if it is correct, and it is correct. Oh, I only sold a 20% one, not 25. So I lied in the beginning. Sorry about that. Oh yeah, I'm currently oh, I think I saw this one before. So normally I do benchmark tests and stuff like that. So I don't know if there is someone who has like a genius idea for this one. Tell me. And yeah, I don't know really what to return. Like, shall I always return the product? But it's kind of somehow weird. So I don't have test cases for this. Because sometimes I just want to live dangerously. Okay, starting with the number 1 and moving to the right in a clockwise direction, a 5 by 5 spiral is formed as follows. Oh no, it's like the exorcism problem. It can be verified that the sum of the numbers on the diagonals is 101. I just believe that. What is the sum of the numbers? Spiral matrix, yeah. Okay, maybe I don't believe that. So I assume that the 1 is counted twice, right? 17 plus 5 plus 1 plus 9 plus 25. Okay, let me check again. 21, 7, 1, 3, 13, 17, 5, 1, 9, 25. Okay, so the 1 is not counted twice. What is the sum of the numbers on the diagonals in the 1001 by 1001 spiral? Okay. Let's call it n, and I'll do it only for square. Okay. I don't want to create that thing, to be honest. So I think there's a way to compute it. So this is, of course, 2 times more than 1. This is then 2, 2, 2. Then it's 4 times, not 2 times, 2 more every time. Sorry. Then it's 4 more every time. Then we would be 26, 27, 28, 29, 30, 31. It would be 6 more. Okay, I think I got the idea. And yeah, it's somehow nice if it's odd. Okay. But it's somehow nice if it's odd. I mean, just assume it's odd. Okay, then we have S. So S is the sum. And then we need to keep, so there's always like the 4 corners. So, and we have 4, basically for 1, 2, div 2, div n 2. So this is n minus 1 divided by 2, basically. Normally, so this one would be 2 cases, and then for j equals 1 to 4. I don't even know why I write for loops for this. Adding gleich sorry, that was German. Adding equals 2. Okay, adding equals 0, and then adding equals to 2. And then we have current adding equals to adding. What do I want to do? So I want to have plus 2 at the beginning. So this is okay, maybe I call it last equals to 1. And then we have last plus adding. And then we have last. Okay, maybe you can do it like this. And I don't think I need the loop for this, but let's try it out. Spiral deck sum of equals 101. And I don't know, does this sound reasonable? Let's have a check. At least it's taking long, right? So it is correct. That was fast. Yeah, and I don't know, it's probably fast, right? Because I'm not doing stuff. You're like crushing everything. I have a good run. Yeah, I don't know why it should, like, I don't know, taking time. Wow, okay. I didn't expect that it'd be like that fast. Is it? I don't know. It's too fast to me. But yeah, well, we are not doing anything, right? So it's okay. But there's no need for improvement, I would say, because all we do is adding integers together, and if the computer is good at something, it's numbers and adding and multiplying stuff. So, we are actually doing stuff. So, and returning something. And yes, I could add a way to work with non-odd spirals, or however you want to call them. But okay. If it's not asked, I don't have to implement it. It would be sufficient to just implement it for 1001, but I have at least implemented a little bit more general version of it. Okay. Consider all integer combinations of a to the power b. Yes. If they are then placed in numerical order with any repeats removed. Are there any repetitions? No, right? But might be anyway. We get the following sequence of 15 distinct terms. Oh, okay, they might get removed. Distinct powers, okay. I think this one is, yeah, they are not too hard this time, feels like. Famous last words. And B, A range, B range, maybe. So I would say we can generate just a set and compute them. Oh, okay, they get quite large. Anyway, let's not think about it, right? Let's implement. Distinct. I don't know. Can't call it distinct powers because that name is used. And for A in A range, B in B range. So okay, we probably want to not compute A to the power B here, but we want to have number I was thinking about A to the power first B range. And then like skip the first. Okay, I would call it A end and B end because I will not support the range directly. As that is a little bit more complicated. So this will be, and this will be 1, 2, B and minus whatever, minus the 1, minus 2, I think. And then I will have basically distinct n. I hope this works. Oh, I think It should be small b. What I want to do is n times a and have stuff like this. Oh, there is actually one which repeats, right? Which one is it? On the 16. Okay. 2 to the power 4 and 4 to the power 2. That makes sense. No. I was looking for this. Oh, not even done an hour. That's quite good. Okay. A little bit confused right now. What do I want to do? Oh yeah, I just included a distinct powers of b and 5 and sorry, a and 5 and b. This is 15. And then we have hundreds and hundreds. Okay, that's still fast. So yeah, people who haven't worked with sets before, so it's basically it's not really a vector. It's basically holding whatever you give in there as the type, as the element type, but only one of them. So like keys in the dictionary, for example. So when pushing it, it will check whether it's there already. And if it's not there, it will push it. It's also not ordered. So it's not like a vector. And this is why the length gives us the correct results. But I'm wondering how fast this is. Oh yeah, it's not that fast. Distinct powers. Of 5 and 5 was 15, and of 100 and hundreds was 9,183. Just make sure. No. Distinct powers. Yes. Can we go? Oh, okay, and then we can actually go to the next one this way. Is there somehow a better way to do that? Because yeah, big integers are not fast. The top of my head, I'm kind of so. Oh yeah, so for example, I could. So, is there any way? No. So the prime numbers power must be distinct. So 2, 3, and 5, for example, will never overlap. But then we have so this one will be the next as 2 to the power 6, so will be removed. And then we could figure out how many will be removed that way? I assume. So, for example, primes of 100 is 25. And then we have 2,500 which have to be distinct. And then we have some in between which are distinct because they are not reached yet. I didn't have any exams, to be honest. So the question in the chat is whether I've done exams now and whether it's summer in Germany. Basically, I only had one seminar this semester, which I had like I was the second who had to present. So that was like, I don't know, 1.5 weeks ago, probably. Yeah, 1.5 months ago, sorry. Or maybe 2, I don't know. I think it started in May. Yeah, 1.5. And I only have to do my master thesis, but that is a little bit problematic at the moment because of Corona, and the number of professors is relatively limited. But yeah, that's for something longer. It's kind of summer, like temperature-wise. University-wise, I think it's still like a month to go for normal students. And temperature-wise, it's kind of colder than previous years, I would say. I'm a poor guy. No, I'm not a poor guy. I can just do whatever I want. It feels like. It sure is summer. Do you think so? So Illustramentonia is in Germany as well, but I don't feel like it's really summer. Like, I don't know whether we have more than 30 degrees yet. And I think now it's like 20. Colder than previous summers. Yeah, that's what I said. So I think I will just go with the next one, and some of have a vague idea of how this could be done in a better way. Is enough for me. I don't know if you. So I hope I can do my master thesis about either Juniper, so the mixed integer nonlinear solver I wrote at LANL 2.5 years ago, which would be nice to have some improvements on it, but I'm currently not working on it. But it would be possible to do that as a master thesis, maybe, or working on my constraint solver. But for both of them, so this university is more artificial intelligence, image processing, and that kind of stuff, which I didn't fully know before I started here. It's kind of a problem. So yeah, I hope I can find someone who does something like that, or I just have to do my master thesis on like a topic I'm not totally interested in, but just to get a master and then do whatever I want. But currently, I just take my time to like work on personal projects, writing blog posts, and stuff like that, which is what I would like to do in the end. But it's it's kind of not that profitable at the moment. I mean, I think I cannot just do that living wise. at the moment. When Julia can grow, when Julia grows, more people can read my blog and more people can pay for it. Maybe, yes, but at the moment it doesn't look like that. Otherwise, I'm interested in, well, general optimization, discrete optimization stuff. So what I probably will do after master, or if I just don't want to do my masters anymore, I would do like try at logistics companies, for example, who need a lot of optimization stuff. Also applied for an internship on like more drug research thing which needed optimization, mathematical optimization. That didn't work out. So, but there are like many fields which could benefit from me. No, yeah. Chris Rakaukas. Yeah, I don't know how to spell his name, so I don't know how to pronounce his name even. But I think it was not too bad. I met him once at Lennel. About internship thesis. Yeah, so thesis I think is quite problematic because you always need a professor at my university here in Heidelberg, which would be willing to do this, and normally they are not willing to do this. Somehow they would just want to like get students to work for them for free, kind of. At least that's what it feels like often. So you do more research for them than doing something for yourself. So I don't know Ludoro, but I can have a look. Yeah, I know. It really feels like that sometimes. Yeah, yeah. I don't know. I find it quite weird. So at my university, where I did my undergrad, it was quite nice. I had a topic I was interested in, but it was too complicated for undergrad, and then he gave me something I can work on. But for undergrad, it's like reasonable that they can't do anything with your work. It's just for you learning. I don't know how it is here in Heidelberg. And at Lanel, it was very nice. It was just a question like, what do you want to work on? And I'm like, I don't know, what do you need? And then we like, they had some problems, and I was like, oh yeah, that sounds interesting to me. And then I worked on it. So yeah, that was quite nice. And got a paper out of it, which was even nicer. But yeah, anyway, let's get back to Project Euler. Please ask questions in the comments if you have any. And I think I will have another sip of this wonderful Coca-Cola from, it's not Coca-Cola, it's Coca-Cola from the Czech Republic, which is quite nice. Just having some advertisement in between. They don't pay me. Not yet, at least. Okay. Surprisingly, there are only 3 numbers that can be written as the sum of force powers of their digits. Product placement. Yeah, I'm working on stuff like that. Okay, a small detour. When I first started with my blog, I tried to use Amazon affiliates and have some books at the end of each post, but it went horribly wrong. Or like I made, I don't know, $15 in like 2 years, and then they kicked me out because I was not valuable for them, I suppose. And then So my only goal at first was to like not pay for my server. And then I started Patreon and relatively fast got the money, like $5 per month to pay for the server and the domain name. And now it's growing. That's quite nice. I didn't expect that. So at the moment I get $24 per month over Patreon, which is quite awesome. Okay. S is not a sum. Yeah. Okay. That makes sense. The sum of these numbers is, find the sum of all the numbers that can be written as the sum of fifth powers of their digits. Okay, so first of all, we probably want to I think we probably want to get how big these numbers can get. So for example, if we have 5 to the power 5 plus 5 to the power 5 plus 5 to the power 5, we are already, yeah, I don't know. No, I was thinking, why does this end at 9,474? Why is there no 5-digit number? Can there be 5-digit numbers? There's probably a really good reason for it. Yeah, because of oh no, because that when the number gets bigger every time. So if anybody has the idea, please tell me. We do it like, I always have problems to name these functions. And then is it reasonable to compute the powers beforehand? Like having a power matrix of something like this, and then basically have at power 1, like 2 is 1 to the power 1. 2, 3 is maybe 1 to the power 2, and so on. And then I can just look them up on the way. I'm not too sure, but somehow, what do I want to do? Somehow seems not too far off. So power of I plus 1 of 1 is 1. So this is like, I don't know, 5 to the power 0, for example. And this is I plus j plus 1. And then 0 to the power 0, which is already back in there. And this is I to the power j. And this is all smaller than in 64, is in 64. Some digit power. Well, it doesn't matter what it is. So this is 9 to the power. Oh. Oh, somehow feels a little bit stupid. We of course only always have power to the always have to the power 5. So we just have this is so weird. Always have this. Sorry about that. What? Okay. 2 to the power 5, 3 to the power 5, 4 to the... Okay. And this is, of course, power, not 5. I don't know whether that's even a reasonable thing to do, to be honest. But might be faster, might not be. Okay, so if we are looking number of digits is 2 to, let's say, 5. I'm wondering whether I'd loop over this or I'd loop over this. So what I mean by that is whether I have 1, 6, 3, 4, 5, or whether I just have like increasing this by 1 every time and always work on digits level and not on the whole number level. Because this one is, I think, slower, then I might start with it. So I have to think about the upper limit again. So the current upper limit I have in mind is something like this. But, oh, do I need, oh, I think I have this in mind. But I don't know whether that's correct. And then basically have digits of n, and have like power of digits of n plus 1. and the sum of that. And if that equals to n, maybe we want to have some output. Oh, naming variables is hard. Okay, so the, oh yeah, this should be 1634820894, and the sum is wrong because we want to start at 10, basically. Yeah, okay. How about 5? And how about we increase this? Okay, they get bigger. To be okay. Huh. So by the way, digits have them in reversed order. So digits of 1, 2, 3 is 3, 2, 1, but this doesn't change. It's not problematic for our case, but might be useful to know for you. But what is the upper limit? I mean, I could just like set an upper limit and check whether it's reached. But there has to be something. Is anyone out there who can help me? Yeah, but oh, I was just thinking about the 0. Okay, one can't add zeros because the n changes. I will try this one just for now. See whether that's already correct. Right. Okay. So we have this seems odd to me. Because when we are over it, we can always add like a smaller number in the end to reduce, or like not really over. If we are over it, we're done. your I is this n, or can you clarify what you mean? So problem is, if we have 9 to the power 5 plus 9 to the power 5 plus 9 to the power 5 or whatever, we are already well, we can still reach this one. I'm super confused. Okay. What is the upper limit? Also, have a check. Quite some memory usage. I don't actually. Does that work? Oh, because this one digits creates, of course, memory. Yeah, that's quite bad. That out. So while in the backgrounds, I can think about the upper bounds. Let's try to make it faster by having a function digit power. Oh, someone mentioned before. Why can't I scroll in the chat? I should use rem diff or something like that. Diff rem, maybe? Yeah. To get what I did before with diff and mods, or like remainder with then what I'm looking for this, which I think is remainder function, right? Yeah. Okay, yeah. I should do so what I wanted to do is have I wanted to have modulo, damn it, modulo 10 to get the last digit, and then I take that as have the remainder which, sorry, that's is the remainder, and then I have divided by, okay, what is it, diffgram d and r of n10 and d equals 1, while d not 0, I have this and have power, and then I have s plus equal d to the, remainder to the power of p. Return s. Well, digit power 16344. No. This should be D. Right? Yeah. 1634. That's what I wanted. No. Digit power of n to the power p. And then I have d notified. Let's be consistent and call it p. This is the correct answer. Should be faster than 200 milliseconds, because there should be no memory allocation, and this one should be relatively fast. Yes. Must after creating a mess. Yeah. Shall I do it more often? No. Yeah, I think often it's running benchmark while the function prints something out, or have like this include and include t problem, where I don't do what I want to do. But yeah, I still by someone you mean you. I can send you all the videos, or you can download them from YouTube. Oh yeah. Oh yeah, I know I knew this name. Sorry, I just had to look at my emails. Yeah, I don't know. This is a to-do. Because I have no idea how to find a good upper limit for that. Expensive solve? You mean my my way of doing it? There's probably something better, you say? Probably there is. So you think there is a better way to do it, or you think it's not quick or both. Well, there's not. I don't know how fast this is and whether there. Yeah, using the power of Julia, I'm faster than Python. Well, I normally think like if it's so, the general rule is kind of you should be able to solve it in less than a minute. And I always think if I'm faster than like, I don't know, a second maybe, then I'm kind of okay with it. Or if there's like, if I immediately have an idea of how to be better, I try to implement it. But for this, I currently don't have the idea. Actually, in the United. Oh, you had one with more than a minute, but I think they. Let me check. Here. Yeah. Each problem has been designed according to a 1-minute rule, which means that although it might take several hours to design, a successful algorithm with more difficult problems and efficient implementation will allow a solution to be obtained on a modestly powered computer in less than 1 minute. And I even, well, there's not much of a change anymore in computing. Like we don't have Moore's law anymore, but yeah, some inefficient solutions. Yeah. I also have like a lot of solutions where I'm sure there's something better. But somehow I'm out of ideas. And for some of them, I just sometimes I feel like Julia with big ints has a lot less problems with some of the project Euler problems. I don't know which one. There was some problem with like a 1,000-digit number or something like that, and I don't know how to do it like in, I don't know, C++ or whatever, which doesn't have big int implemented. I think. Correct me if I'm wrong. I think Python has that as well. So well, they have a big int, so they shouldn't have a problem with that. Whatever. Problem number 31. In the United Kingdom, the currency is made up of pound and pence. 8 coins in general circulation. It is possible to make $2 in the following way. Yes, and it's only one way, right? Can also just take 2 parts. Normally they give like a list of the ways one can do it for like a small example. How many different ways can $2 be made using any number of coins? Wow. Okay. I think that's something. I don't have cases. Okay. Something I have to think about. So there's like the obvious one. Just take the $2 one. Then we have like 200 pence solution and everything in between. So what I'm thinking about is having a dynamic programming structure in it. So if we know that for 2 pence we have 2 possibilities. One is 2 pence and the other one is 2 times 1 pence. And then we kind of work up on that. And maybe, oh, no, okay. Coincidence. I don't know why it's coincidence. Coin possibilities. Value is 200. And then we have like a list of coins, which is 1, 2, 5, 10, 20, 50, 100, and 200. Oh, do I want them? Oh yeah, I don't know. I was just thinking whether I want to have them in reverse order. I think I don't want to. But I might want to have them outside. Then I was thinking if is there a problem? Yeah. So there is this nice package called Memorize, I think. Yeah. Which has some nice features. So I spelled it correct. Just have to install it. So basically it saves the results from a call. So that way you can do a recursive Fibonacci fast, for example. Oh, by the way, if you're still there, M2EU, do you have like a favorite problem that you have solved already on Project Euler? Yes, this looks weird. So my idea is and yeah, I sometimes don't know why to download that much stuff. Like the JPEG one has probably nothing to do with Memorize. 312. Okay. It's not on my list, but it's the Sierpinski graph. Oh, that's nice. Oh. Yeah, okay. Oh. More to read. The number of cycles was exactly once. Oh, wow. That sounds nice and complicated. Interesting. Okay. Wow. Feels like this one is just too easy for you. So yeah, what I wanted to do is I think it happens done that. Is basically check whether value is bigger than the coin, and if it's bigger than the coin, I subtract it and check again. So if value equals to 1, return there's one possibility. Otherwise, for coin in coins, if value smaller than coin, it can be done by hand. You mean 312? Or the problem I'm working on? I'm confused. Wow. Okay. That's awesome. Okay. That's impressive. It looked very interesting and hard. So because it's sorted, if the value is smaller than the coin, we can break, and otherwise we have okay, now I have to think about recursion again. If I have 2, then and if it's correct, oh no, I think I want to do this. And have basically does this work? Like P for possibilities. Oh no. Sometimes I'm really bad at recursion. So I want to have coin possibilities of value minus coin. And then I need to get the number of possibilities that I can get. And if I have 2, this would for example, if I have this, does that work? Yes. If I have 3, I have 3 possibilities, because 1, 1, 1 and 2, 1 is the possibility. Now I have 1, 1, 1, 1. I think that was 1 too much, but 1, 1 plus 2. 2 plus 2 is... Oh. So the problem is that I have if I subtract 2 first, and then I have 1, 1. I'm currently a bit confused. Why are there 5 possibilities? even with my error. So the error is that I want to like always, if the biggest coin I've added, I want to add only bigger coins. So if I've added, but this doesn't work out. No. What I mean is this should not be a possibility, or this should not be a possibility. They should not be counted twice. And okay, so this one and okay, now I'm close to the 5 possibilities. Which one am I missing? Oh, I think I missed 2 plus 2. Okay. But there's actually only this one, this one, this one. So there are only 3 real ones. But how do I change that? Okay. Something like this. And if coin is smaller than max coin, we just continue. Yes. That makes sense. It's kind of tedious. 1, 1, 2. 1, 1, 1, 1, 1, 1, 1, 1, 2. 1, 2, 2, and 1, 5. What? No, just 5. Okay, 4 possibilities. That seems to be okay. Not sure whether that is like so the problem with that is if I have I don't know, some value for it and it is like odd, but not divisible by 5, I will never reach 0 directly. And then it just calls it, but there's no input. So like a small value smaller than 0, return 0. Works. But yeah. Well, if it's correct, it's fast. Hate those ones. And then, yeah, besides Project Euler, I haven't seen them for a while. Oh, that's correct. Because I think they are solved by computers. Oh, I'm streaming almost 2 hours now. Let me do some quick benchmarking. Nanoseconds. Wow. Actually, like this one more, I think. I think it's quite readable, and with Memwise, it's quite nice. So the Memwise one is basically if we have at some point we called it with 3 and that's why Memwise is that's why benchmarking it is kind of stupid at the moment, because we memorized it. Yeah, that's kind of stupid. And I don't know how to benchmark it otherwise. So basically, we would otherwise need to have a list of what we've tried already, like a dictionary, and the result for it. And then if we store the results, whatever. Yeah, this is super stupid. I don't know. Maybe there is like a way to drop. No, always. That one was for you again. In the chats. Said I always say no, 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 no. And I lost the chat. That's even worse. We appreciate it. Yeah, thanks. Yeah, I don't know what. Oh yeah, I wanted to have memoirs. Can specify some kind of bits, but there's no documentation. Okay, whatever. Please give us some time to type. Type what? The chat when I say no, 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 no. This one was 31. Yeah, please take your time. Oh, a small break for me. Okay. Oh yeah, I haven't written any test case for a while. Pen digital products. We shall say that an n-digit number is pen digital if it makes use of all the digits 1 to n exactly once. For example, 1, 5, 2, 3, 4. Yes, the product 7254 is unusual as the identity. Oh, okay. 39 times 186 is 7254, which contains all, well, multiplicand multiplier. Why are not both multipliers? Okay. Is pentadigital. Find the sum of all products whose multiplicand's multiplier product identity can be written as a 1 through 9 pen digital. Okay, some products can be some of the products. Okay, some products can be obtained in more than one way, so be sure to only include it once in use. Okay. So what I'm currently thinking is we can have permutation, which we found out earlier, like in previous streams, that permutations are low implemented in Julia. But okay. And then for all the different possibilities, we just like we could have 3 times 9,186. 391 times and so on. So they are different possibilities. Is that a reasonable thing to do? I don't know, but it's a naive thing to do. Pen digital. Whatever. We don't have any input. We just want to have 1 to 9. I don't know which package we need. Oh, there's like a permutations package. Hmm? What? I have the feeling. Oh yeah, Jacob, it's nice that you are still here. I don't know. Currently have quite some fun, so maybe 30 minutes. Normally I only do 2 hours, but I don't have anything else to do today, so I think I will be here for at least 30 minutes. I don't actually get what they're doing. All right, see you then. Combinatorics is what I wanted. So I have this is what I want. And yeah, I have to be careful with this one. But for now, I will use a set for it. And just, if it's in the set, I don't compute anything. Okay, then I have pointer 1 is basically where do I want to the pointer afterwards? That sounds reasonable. And we have 9 digits. So I don't know. It's 8 and probably even less. And this one is I plus 1 also to 8. And then we have is there something like the reverse version of the digits? Yeah, something like this. That's actually quite good. Yeah, the naming is terrible, but okay. So what I want to do is I have base 10 and I have it's in the wrong way, I think, right? So I want to have the first array. Oh, it's actually seems to be correct. Oh, it has to be length of array minus k. Is that correct? Thanks. Okay. Oh yeah. Could even write it as an actual one line. If a little bit long. Okay. Then I wanted to do we have n times m equals k, for example, so that we have n is array to int of perm from 1 to we probably want to have a view of that. I think that should work. I then we have m is I and j, and k is basically the rest. It might be quite expensive. Oh, this should be like 1. This should be j plus 1 if I think this correctly. And we have k. No, we have if n times m equals to k, then push it to product set. Push k to product set, and then basically return sum of product sets. And Okay, so I have to think about this again. So this can contain up to 7 numbers, I think. 7, 8, and then 9 is the end. Oh, and I want to. So this is r minus 2. This is r minus 1. Length of. I don't know. Seems a bit hot, but okay. Is there any way? No, there doesn't seem. No, doesn't make sense. Okay. 7-element array. J is 2. I'm super confused. We used n somewhere else. 1, 2, 3. So, yeah, that's just the first one. Currently really confused. Is it because of view? So if we have and then we have view of a, I think, 3 ends. Okay. I normally always use the shall I have to write it like this. And why is it not a problem before? That's, okay. Just to try it out. 7254. 5796 on twice. 3 times. 4 times. Okay. And yeah, it's not that fast. More about that later. 82103. Okay, that is correct, but it is low. I'm not printing that out. So both of them have 4 digits. That's probably reasonable. Oh. And everything should appear at least twice. So yeah, the kind of... Oh yeah, that's super bad. Yeah, kind of stupid way. To be honest. So one problem is this N and M can, at some point they always turn out to be this, not the same, but at one point we will have 186 times 3, 9, which will of course be the same. So one thing we can do is the first one has to be always smaller than the second one, which should cut it. But yeah, this is really bad. Oh, what the hell? Why are they doing that? Two, three. Not really fast, but it should have less memory allocation. There was a memory allocation for every sum, which was super bad. But yeah, it's still not fast. But I hope the memory allocation cut in half. Okay. Then we have, where is the memory allocation? Permutations has some memory allocation. So if j minus 1 is smaller than I, we continue. So M should have at least as many digits as N. It doesn't feel like 1.5 seconds. I don't know what's going on there. Okay. But just to be sure. This seems not right. Yeah, this is not correct. Oh, sorry. Yeah. Okay. That is better, but not really good. I somehow don't want to create permutations by myself by adding yeah, I don't know what's the best way to create them in the first place, to be honest. There's probably a good way of doing that. But I'm still wondering what this takes so much time. Less than a second, that's all right. Then one other point is this can't be it's not so clear. Yeah, it can be a one-digit number, but it can definitely not be one. And we kind of don't need all of the so another one is if m smaller than n, then continue. That's much better. Okay. Let me yeah. Where does that have memory allocation? That seems a little bit odd to me. And this is not... Okay, maybe we should do that a little bit differently. It's still something. So input and check. Okay. I don't want to have the array in the first place. Oh, well, for that it's quite nice actually. I don't know, it's another one of... It's another one which can be improved, I think. But we solved it. So can be happy with that. Okay, the fraction 49 over 90 is a curious fraction. As an inexperienced mathematician, in attempting to simplify it, may incorrectly believe that 49... What? Oh, okay. I gotcha. So 49 divided by 98 is a half. So 4 divided by 8. But it's not because the 9 cancels out. You shall consider fractions like to be trivial examples. There are exactly 4 non-trivial examples of this type of fraction less than 1. Oh, less than 1, okay. So A divided by B, where A is smaller than B. And containing 2 digits in the numerator and denominator. If the product of these 4 fractions is given in its lowest common terms, find the value of the denominator. What the hell? Okay, there are 4 fractions. Its lowest common terms. Does that mean 4/8 is like 1/2? And then we multiply it out and okay. I hope I understood the question. So we are first trying to find the four non-trivial examples where this is the case. So we have for A 1 to 99, for B equals less than 1 in value, so it's actually B is A plus 1 to 99. Oh, it's like 2 digits. This should be fine. And we need, I don't know. So we probably need that one of the digits is the same, right? It's such a weird question. This is also a little bit weird, to be honest, but okay. And then, oh, this should be 10. If A1 B1 or A1 equals B2 or A2 equals B1 or A2 equals B2, then print A and B. By the way, what are you doing while I stream? Are you coding as well, or what are you up to? Just having me in the background, I guess. Or is anyone seriously watching? Think this works. Oh yeah, if A2 equals, oh, a Julia API for Anki. So you want to, oh really? You're trying to come up with a solution? Why are you not telling me? So I just want to finish that. So by API wrapper for Anki, you mean being able to add Anki cards from Julia and getting them in return as well? Or, and what is the use case for it? Yeah, probably tell me about the use case. Why do you want that? I didn't know that that Anki has like an API ability, but I guess Anki is open source and it's open source, right? Okay. Yeah, I think so. And quite a lot of people use it. So if there's any need for an API, somebody probably implemented it. Oh, okay. So like more downstream from Anki to Julia and not the other way around. Okay, I actually wanted to find them first. Okay, damn, I had to write this down. Anki Connect. Okay. Yeah. So you're using Anki for probably learning languages like Arabic and Spanish, and also for some mathematics stuff, or what are you using it for? So I don't know whether if A1 equals B1 and A divided by B, I just write it like this. Mathematics, neuroscience. Neuroscience? You're interested in neuroscience? That's awesome. I'm interested in neuroscience as well. What are you, do you read any books on neuroscience? I feel like I'm a little bit slow. Okay, so just have to check 2/3 equal 4. That is correct. Okay, I was interested in that. Okay. I just copy that into a Google search. I haven't heard about them. All right, see you then. What I'm actually okay. A list of rationals, and I put in there this. Yeah, I don't know. Probably this is easier. Else if A is equal to B1, then this. I always do the same thing, which is kind of whatever. A2, A2, B1, B2, A1, A, B2, B1 seems to be correct. Oh, damn it. And of course, I want this should give me 4 terms. And it does. And now I want to have P terms is product of terms and return them. Oh, it's actually called denominator. Perfect. I think. 100. So and always I see something like this, like 100. I always get like, oh, sounds like a simple answer. Maybe with some more thoughts, one might could have like figured it out, but I don't know. Yeah, and I'm using kind of the rational built-in of in Julia, which feels a little bit like cheating, but okay. At least not too slow. I always like not divide by 0 is also quite a good idea, I think. That doesn't change anything. Okay. Oh, hi Jacob, you're back. Okay. Get back. Yeah, no, it's not. Oh yeah, I wanted to. I think this should work as well. I don't know whether that's more readable or not, but yeah, it feels stupid to have it 4 times. Going strong today. Let's do one more. And then finish it up. Okay. 145 is a curious number. Yeah, everything is quite strange on Project Euler. Because the digit factorial is 145. It's actually quite nice. It's always something like feels a bit like number file videos. If you don't know number file, you should check it out on YouTube. 145. Find the sum of all numbers which are equal to the sum of the factorial of their digit. Oh, no. Tom Scott is your favorite? But he's more on computer file, right? Does he do some stuff on number file as well? I'm not sure about that. But he's a linguist, right? It's super strange. I always thought like he studied studied computer science, but I think he studied linguistic. Okay, yeah. I think my favorite one is Dr. James Grime. But I'm also a huge fan of Matt Parker, Simon Pampena, Simon Singh. Yeah, a lot of great people there. Anyway, now this is always like I have to always think of an upper bound like before. So This is not possible, right? Okay. I was just thinking might be. Yeah, to which points, like, am I going to have to do these checks? So I can use like my famous not so awesome digits one again, with memory allocations all over the place. Or I can have this is a little bit strange. So if it's an odd number, I have to include the 1. Otherwise, it's either. Do I have to save the factorials somehow? Currently wondering what is a good way of doing it. So I could use I either iterate over the number itself and just check it, but how high can this number be is a question. I think I should solve this question first. And I'm actually not too sure how to. Why can't there be like a really large which has this property? In the way. What does reduce actually do? Okay. I was just thinking whether one can write this in a very easy form, like reduce over sum, reduce over plus, or whatever. Okay. How do I get the upper limits? Okay. Anyway, so I am going to implement starting from 11 going up to, I don't know, 10,000. So iterating over this number. Then I have the digits, which are reversed, but I don't care about that. And I have factorial over digits and the sum of that. And if this is n, I want to add it to the sum. Okay. return. Found $n. 145. Yes. Upper. There's another one. 10 to the power 10. Yeah, okay. Either there is no other solution, or it's quite big. Oh, wait. Oh, I'm doing it wrong. I actually wanted to have something like this and not so big, maybe. Yeah, so the +2 is not reasonable. It's just that if I have... What's going on with this one? What? Oh, because this is also... This is also 1, right? Yeah, okay. So it has to be a 0 or a 1. And if it doesn't, it would be even. Okay. Because I'm a little bit out of idea currently. Did it change? 8, 9. If this is the case, it's quite a short list. It is the case. And I'm not happy with it. Six solved. No, I'm actually... I started with 26, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 solved, if I counted correctly. So 3 per hour. It's not too bad. That's I think so. This one and the other one with the upper bound is more like a guess and not a real proof. So I'm not too happy with it. This seems weird. It's probably even not. It's also not fast, but that's another point. So. the question of today's stream is, what is the upper bound? Yeah, I think about that for a while off stream. It somehow feels possible that there is something like big. So we have factorial of 9. And then we could plus that to a factorial of 9. But that has to appear in that. And I might have to. I think it's not wise to start from there. I think there's like a reasonable solution with starting from the digits and then kind of looking into the future whether there is a possibility. So, for example, if I'm no, because it's even if I'm bigger than something, I can't just stop because like 14 or the factorial is 25, then it's bigger than 14, but I can add something. I don't know. It's a little bit weird. Yeah. So, yeah. By the way, Jacob, if you're still there, and maybe others as well, but I now know that you're watching Numberphile. Have you seen the 3 blue 1 brown video about the chessboard puzzle? Because I find that quite awesome and I haven't been able to solve it yet. So for everyone, there is basically oh, he's like the best YouTuber ever. Get out of here. No, why don't you like him? I really like his visualization. So I don't know whether that looks that looks quite decent. So let's assume you have can't even make it awesome. Okay. Let's assume this is a all right. This is a chessboard. So it has 8 times 8, and there are coins on top of it, and some are tails and some are heads. And there are 2 prisoners. So I don't know. I'm a huge fan of prisoner problems where you try to get out of the prison by solving a mathematical puzzle. So one point is one prisoner gets into the room and then sees that there is a key behind one of those fields, like for example this one, and he is allowed to flip or he must flip exactly 1 coin and then get out of the room, and the other one gets into the room and has to say where the key is. So for example, if this coin is flipped to a 1, he has to compute somehow that the key is there. For example, if this is the right solution, if I don't know what the solution is. So I have like a 75% solution, but there should be a way to have like 100% solution to get it always right. I think I got nerd sniped with that problem. Anyway, that's always at the back of my head. If you have time and want to think about it, watch the video 3 blue 1 brown, the Impossible Chess Puzzle, I think, and a cooperation with Matt Parker, who is also a Numberphile, the not impossible chess puzzle or almost impossible chess puzzle or stuff like that. Anyway, yeah, that is the stream for now. Problem number 34 solved. Some to-dos, which maybe I do next time if I haven't forgotten them. Like if I solve them in between, but normally I don't have a look at them in between. I will tell you again. Probably. Sometimes my phone gets a little bit hot, which is the webcam for the stream. Yeah, I'm glad that you dropped in this time. So as always, for the people who watched before, I have a Patreon page, which I think you're all watching on. Let me fix this. Let me fix this. Why is restream not possible to? Where do I have to go? Stream manager seems to be correct. Okay, so that's the link to my Patreon page, and sorry about that. So normally I block on open sources, which is spelled like this, where I currently blog about my constraint solver, or haven't blogged about it for a little bit actually, because I blog about a new series called Julia Basics. So if you're new to Julia and want to learn some awesome stuff, check out that series. And I am on Patreon since May last year or stuff like that. I get some money since September last year. And I have now 4 tiers. So one is just $1 per month, and you get per posts I blog, or my blog posts and videos if I get my cutting program video cut software working again and solve the segmentation fault. I hope I can do some YouTube videos, so you get them earlier, 2 days earlier than anyone else. Live streams are of course live. There's not much I can do about that. Then there's a $4 tier, which so there you can see the people listed here. 4 people currently pay over $4, so 4 or 10, and then they get listed after each video, live stream, and blog post. There is a $10 one, which is just my, or $10.10 one, which is just a binary hero one. And the last one I've added yesterday is for $50, where I do code reviews for beginners in Julia. So if you're a beginner in Julia and have like a personal project, I would like to help you with that in a way that I review your code, so you don't have to read the full documentation of Julia to get everything. And everybody makes mistakes at the beginning, and I always still make mistakes, as you have seen in the stream. But I do mentoring on exorcism.io, and I want to extend that to personal projects from my viewers and readers. So if you're interested in that, please reach out to me. So yeah, thank all my patrons or patrons for their support. So that's super motivating. And I also want to thank my anonymous friends for their intro music, which probably people have, or like I don't know how many missed it. I need to find a way to play it like now. But I still haven't managed to do it. Sorry about that. Anyway, oh yeah, I'm thinking about doing another stream on the weekend on HackerRank with Eval again, if he has time, or I don't know, maybe someone of you wants to join. So we do pair or triple programming, or if someone wants to join on some HackerRank challenges. We failed miserably last time. Hopefully we'll get better. So yeah, it's just and it will be like earlier because he's from Australia or living in Australia. So it will be like 8 a.m. UTC, 10 a.m. UTC, something in that range. Sorry for everyone from the States. But this one is better for you. So my Wednesday ones are terrible for Australia, but good for like everything from West Coast to I don't know, Middle Eastern time, somewhere along those lines. Anyway, thank you everyone for watching, and see you either on the weekends. I will post it on Twitter, or like in 7 times 24 hours minus 3. So next Wednesday. All right. See you.